My name's Mark Ryan. I'm going to show you a quick example of deploying the Zscaler workload segmentation agents programmatically in a AWS environment. So I'll briefly just show you the API examples that exist on GitHub. You can take a look through these examples. There's a couple for how to add collections and segments and download logs. Basically all of these will call the Edge Utils Python library here, which basically goes through, grabs a configuration, authenticates to the API to get your OAuth token, and then enables you to get, put, post, delete, and whatever into the API. So that library reads in the configuration. So it needs to know the URL route, the site ID, username and password for the API, and public-private key for the certificate for the MTLS tunnel to be created. So what I've done is I've taken this and applied it to an IaaS environment. So the first thing I've done is taken those parameters and stored them in the parameter store in Systems Manager. So the certificate, we're encrypting them using KMS in the same way that I did for programmatically deploying app connectors. So I've got a certificate stored in there. If I look back at the parameter store, I've got the private key that's associated with that there as well, but I've also got the site ID information, and the URL route in my case is z.edgewise.services. So I've got all of the configuration parameters. Obviously I've got a username and client ID and client secret as well. So all I need to do is pass those through to a script in my EC2 instance to be able to go off and programmatically deploy. And the first part of that, if I go down to my configuration, so this is the script, the AWS environment. It figures out what region I'm in by looking at the metadata. We've got to have the Boto3 library, which is the AWS tools, and I'm also going to call OS and sub-process libraries to do certain things with the disks and files. I need the requests library for my HTTPS requests, and I use a temp file library to write a temporary file, and I'll explain that in a second. So once we've figured out which region we're in, I can then use KMS to pull those parameters down. So the key, the certificate, the client ID, client secret, site ID, and URL route. So when I've pulled down the certificate and the key, the requests library actually needs to, or wants to, read the public-private key from a file on disk. So what I actually do is I go ahead and I write it to a temporary file briefly, and then I reference that file in the configuration JSON. So the configuration JSON has the URL route, the site ID, username, password, certificate file, and key file. And then I can call the Edge Utils API session, pass it that configuration to get my OAuth token. So then I can use the API to query the list of installers that are available, and then I can, based on that list of installers, I can take the OAuth token from it, and then I can go ahead and download that OAuth token. I can go ahead and download that installer to a file. And then I go ahead and unlink these files from up above here, which were the temporary files, and they all get deleted and cleared up from from the disk. And then once that's done, I will run a yum install for that file, and then I'll go ahead and install it. And so what I've done, and I showed this in the API demonstration for Zscaler App Connector, is I've built my own app connector programmatically, and so this goes ahead and does exactly that as a script. So it puts that onto the connector as a Python script in the opt Zscaler bin directory. So I've already built my AMI. Here's the AMI that was created. So I can go ahead and launch that AMI. I will use a T2 micro just for this demonstration. Obviously you wouldn't use that in production. And all I need to do is pass it the IAM role. And that IAM role has the ability to read the Systems Manager parameter store, as well as access KMS for the key to decrypt those parameters. And then all I need to do then is pass it the metadata, the user data that basically runs the ZPA app connector provisioning. So we'll provision a new app connector, and the Python script to provision inside of ZWS. So before I do that, I'll just show you in Edgewise I've got no app connectors deployed, no agents deployed. We'll just go status of any agent is either connected or disconnected. And then in Zscaler private access I've got no app connectors deployed either. He says. So I'll go ahead and I'll review and launch that. I'm going to launch it into a public subnet for this demonstration. We'll launch the instance, and that will go ahead and start up. Let's just refresh that. So we're pending. I've got my internet FQDN. So what we'll do is we'll come to the command line SSH NSI ID admin at. We'll wait for this to come up. It's initializing. So it should be online shortly. We'll give it a second to be available. Give it another go. There we go. We're online. It's a new instance. So remember, the scripts are now running to install the Zscaler web workload segmentation agent as well as ZPA agent. So I can sudo to root opt Zscaler bar. So the app connector has provisioned. We can see that 904. Yep, we're in GMT versus BST, and if we we'll see Edgewise has come in there as well. So if I come across here, there we go. We've got our new agent connected 21 seconds ago. And private access, if we refresh this, we've now connected our agent. So we can view the details on this node. And we're all up and running. We can now start adding that to groups and starting to segment the traffic that passes through this this Linux instance. And of course, I've run it on this Linux instance, which happens to be my app connector, but I can then use this script. I can drop that script onto any of my Linux instances and programmatically read those systems parameters and deploy the workload segmentation agent wherever I want. I hope that's useful. Any questions, let me know. Mark at Zscaler.com.